Alright class, in this session we are going to continue with the topic permutation and combination, and we are going to start the exercise of permutation, right? Up till now we have discussed about the concept of permutation, concept of factorial, right? Now what is a permutation? It says different arrangement of letters is called a permutation, right? Now in permutation what we focus on the order. Now what do you mean by order? Let me give you an example here. Let's suppose that you set your password, alright, and your password is PAK456. Let's suppose that is your password, alright. If you insert the password like 564AAP, does it work? It won't work, because passwords need to be set or need to be entered in the same order as it was set. So you can say that the arrangement is very important, alright. The order is very important. If at the initial it is P, so it must be P at the beginning of your password. Although the characters are same, but it won't work because the order is different. So when are we talking about permutation, we need to focus on the order. It must be order must be same. Alright, we are going to attempt some of the questions from the book and examples from the book to understand the concept of permutation. And before that, the working formula for permutation we are going to apply is NPR is equals to n factorial divided by n minus r factorial. Now we had a clear idea that what is a factorial and how to find the factorial we had discussed in the previous exercise, right? So NPR, this letter P you can find out on your calculator, alright. NPR is equals to n factorial divided by n minus r factorial. That is the working formula we are going to apply in this exercise. Alright, so before proceeding towards the exercise, let me give you an example so you will have an idea about the permutation. Now it says that a security code. Now whenever it says code, that means the order is now important, right? A security code consists of 3 letters selected from A, B, C, D, E, F, followed by 2 digits. So it is from 3 letters and 2 digits from 5, 6, 7, 8, 9. Find the number of possible security codes if no letter or number can be repeated. So you need to use the number only once or letter only once, and you need to find out the possible security code, that how many possibilities are there if there are 3 letters and 2 numbers. So the first approach is, you can say that we have 6 letters, right? There are 6 letters A, B, C, D, E, F, and among those 6 letters you need to select 3 of them, right? So you can say that it's 6 permutation 3. Out of 6 letters we need to select 3. So this number at the top it shows the total, right? And the bottom is the number of options that we are going to select or choose. Alright? So 6P3, that means that there are total 6 characters and we are going to pick 3 of them. So it's 6P3. And after that it says followed by 2 digits. Now there are 5 numbers, and among those 5 numbers you need to pick 2 of them. Alright? So the final answer you can say that it's equals to 6P3 times 5P2. When you solve it, you will get the values. 6P3 is equals to 120 times 5P2, that is equals to 20. Alright. So when you multiply 20 and 120, you will get 2400. It means that there are total possibilities of 2400 security codes, but the condition is what? You have 3 letters and you have 2 digits from 5 digits. Alright, that is the working of permutation. There is another way of explanation which might be, you will find it very easy. Now what is that? Basically, we are looking for 5 digits, right? 5 characters, you can say that. And among those 5 digits, we have 3 letters and 2 numbers. So I am saying that we have 1, 2, 3, 4, 5, right? These are the 5 numbers for our security code. and the condition is that for the first three characters we have alphabet. Now, the total possibilities for the first character here, there are 6 total possibilities, right? So the first possibilities, there are 6 total outcomes for these 6 characters, right? Either at the first place it can be A, B, C, D, E, F. So when you pick the first one, for the next space you have 5 possible outcomes because one letter has been picked at the first place, right? And for the next one you have 4 possible outcomes. Now we have picked our 3 characters from letters, right? From A, B, C, D, E, F we have picked 3. Now we need to pick 2 more but from the numbers, right? So we have 5 numbers. So there are 5 possible outcomes for the first number, either it can be 5, 6, 7, 8 or 9. But for the second place it's 4 options only. So you need to multiply all those numbers, 6 into 5 into 4 into 5 into 4, right? So we can verify our answer, that will be 6 into 25 into 16, and you will get the same value, that is equals to 2400. Alright, so both of the ways are correct. It's totally up to you which method you find easy, so you can do it according to your own comfort. Alright, after this example we are going to proceed with the quick questions. So it's question number 1, and the question says, without using the calculator, find the value of each of the following. Use the key NPR key on the calculator to check your answer. So you need to solve without calculator, but you can verify your answer. So for the first part it says AP5, alright. The working formula we had discussed previously is NPR is equals to n factorial divided by n minus r factorial. Alright. Now we have the value for n is 8. So we can say that it's 8 factorial divided by 8 minus 5 factorial. Or we can say that it's 8 factorial divided by 3 factorial, right? 8 factorial is what? It's 8 into 7 into 6 into 5 into 4 into 3 factorial divided by 3 factorial. These two can be cancelled, and you can multiply all those numbers to get the final answer, and that is equals to 6720. That is your answer. Alright, so you need to write down the solution in your copy, and you need to attempt part C here by your own, and you have a time of 2 minutes for these 2 parts, so start. Alright, for part C, what we have done is 11 to 8, so you can say that it's 11 factorial divided by 11 minus 8, it's 3 factorial, right? 11 factorial is 11, 10, 9, 8, 7, 6, 5, 4 and 3 factorial divided by 3 factorial, that you can cancel, and the leftover is your answer. But in the denominator we have only 8 factorial, right? So that will be like this, 8 factorial, 8 factorial cancel. So the answer you will get is 990, and that is your final answer. After this question, moving on to the next one, it's question number 3. And the concept is almost same we had discussed in the example. How many different 5-digit numbers can be found from the digits 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? No digit can be repeated. Alright. So we are looking for 5-digit numbers. So what I'm doing, 1, 2, 3, 4, 5. Alright. How many numbers we have from 1 to 9? It's 1, 2, 3, 4, 5, 6, 7, 8, 9. So total we have 9 numbers, right? And out of those 9 numbers, how many numbers we are looking for? We are looking for 5-digit numbers. We can say that it's 9, 3, 5. When you solve it, you will get the answer. It's 9, 3, 5. So that is equals to 15120. Alright, 15120. That is the first sentence, right? We can do it in the same way, like here. What we are going to do, we have total 9 characters, right? So for the first place, we have an option of 9 characters. Of those 9 characters, we can place any character at the first place, right? And after that, it will be 9 into 8 into 7 into 6 into 5. So when you solve these, multiply all these numbers, you will get the same value. It's 15.20. Alright, so we have 60 seconds to note it down in the copy, so start. Alright guys, after that moving on to the next one. It's question number 5 from the same exercise 10.3. Find how many different 4-digit numbers greater than 4000 that can be formed using the digits 1, 2, 3, 4, 5, 6 and 7 if no digit can be used more than once. Now we have a condition here, although that it is a 4-digit number, but the condition is it must be greater than 4000. Alright, we have done such type of questions when we discuss the concept of factorial, right? So first we need to think about it by yourself, and for this question you have a time of 4 minutes. Give it a try. Start. Alright, so we are looking for 4-digit numbers as 1, 2, 3, 4. The condition says it must be greater than 4000. Alright, that means the possible options for the first place is it can be 4, it can be 5, it can be 6 and it can be 7. So there are 4 possible outcomes, and out of those 4 we can select only one. Alright, so that is the case for first place. You have the result is 4P1 because we have 4 options, and among those 4 options you can select any one. Alright, so we have total 6 digits, right? 1, 2, 3, 4, 5, 6, 7. So 7 digits we have, and out of those 7 digits we have picked 1. That means the leftover digits are 3, and among those 6 digits we need to select 3 of them to fill these 3 places. Alright, so the final answer it will be 4P1 multiplied with 6P3. So you will get the value of 480. That is your answer. Alright, I hope the concept is clear, and all of you can do it easily. After that, moving on to the next one, it's question number 6, right? And the question says, find how many even numbers between 5000 and 6000 can be formed from the digits 2, 4, 5, 7, 8 if no digit can be used more than once. Now the condition we have, it might be an even number, right? And for even number we have discussed the concept in the factorial exercise as well. So you need to give it a try first, and for that part you have a time of 5 minutes. Alright, so give it a try. Start. Alright class, I hope that you have tried this one. So we are looking for how many? We are looking for even numbers, and it's a 4-digit, right? So I'm going to make cases here like I have done in the factorial exercise. We have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Since we are looking for even numbers, so we need to finalize the last place of this number, right? So even numbers we have, either it can be 2, either it can be 4, or either it can be 8. So we have total 3 possibilities for even number. After that it says the number between 5000 and 6000. Alright, so what does it mean? It means that the first place, either it can be 5. If I am going to place 7 here, so that will not be the possibility because it exceeds this range of 5000 and 6000, right? So for the first place we have only one option, and that is 5, and this option is valid for all 3 cases. Alright class, the number is between 5000 and 6000, and it is an even number. So we have finalized the places here. Now the leftover part, out of how many numbers we have? We have 1, 2, 3, 4, 5. Out of those 5 numbers we have selected these 2 numbers. That means the leftover part is 3, and among those 3 you need to select 2 numbers, right? So it's 3P2, 3P2 here, and 3P2 here as well. So when you solve it, it's 3P2, that means the answer is 6, 3P2 answer is 6, 3P2 answer is 6, and we need to add all those answers. Keep in mind that 5, we are not going to multiply with 5 or 4, because this 5 is showing that the first place is reserved by one number, and that one number is 5. So if you want to multiply, you can multiply by 1 only, not with the 5, because there are no, it is not showing that there are 5 possible options. It is showing that it is occupied by one number and that number is 5. Alright. So when you add all those together, you will get the sum that is equals to 18. It means that there are 18 possible outcomes. If the number is between 5,000 and 6,000, it can be even, and these are the numbers 2, 4, 5, 7, 8, which are going to make 4-digit numbers which meet these conditions. Alright, so I hope that you are getting the idea, because the same approach questions we had discussed in the factorial exercise. Alright, now after that I'm going to give you one example that will be on the same factors question we had discussed. It says find how many even numbers, and the first condition is we are looking for even numbers between 3,000 and 4,000, right? So that is the second condition, which is quite same in the previous question. Can be formed using the digits 1, 3, 5, 6, 7 and 9. Alright. So you need to find out the even numbers that lie between 3,000 and 4,000. Give it a try by yourself, as I have done the previous one, and you have a time of 5 minutes for start. Alright, so what I can do, I can make dashes here, 1, 2, 3, 4. Alright, now this time we are not going to have places here. Why? Because we have only one number which makes it even. So for the last place, it is confirmed that the last digit should be 6 to make it even number. Alright, if we have different even numbers, then we have different cases, but for this question we have only one even number, that is 6. After that, what about the starting 3 numbers? It says the number then between 3 and 4,000, right? That means the starting position, it will be only 3, right? Because we don't have 4 here, it is only 3. If the number starts from 3, that means it lies between 3 and 4. Now keep in mind that is not the options. 3 defines only that there is only one number 3 which can be placed at the first place. What are the middle numbers we have? How many numbers we have? We have 1, 2, 3, 4, 5. We have 5 numbers, right? Among those 5 numbers, 2 numbers have been picked. That means the leftover part is 3P2. Not 3, it is 4P2, because I forgot 9 here. So it's 4P2 that we have. 4 numbers left over, and we need to select 2 of them. Alright, and it is equals to 12. Alright, 4P2 equals to 12, and that is your answer. Alright, so that is a very same basic example we have done previously. And for your homework question, what you need to do, you need to attend question number 2, which you can see on your screen. Alright, that is your homework question. Alright class, so I think that is quite enough for today class. Inshallah in next class we are going to continue with